Deep dive, choosing the right algorithm for rate limiting. Selecting the appropriate algorithm is the backbone of designing an effective rate limiter. Each algorithm has its strengths and weaknesses, depending on your system's needs. Let's explore the options in detail. 1. Key considerations for choosing an algorithm. Before selecting an algorithm, answer these questions. Do you need smooth traffic control or allow occasional bursts? How predictable should the rate limiting be for users? Is fairness among users important? What level of complexity can your system handle? 2. Popular algorithms for rate limiting. A. Fixed window algorithm. How it works. Requests are counted within fixed time windows, e.g. 1 minute. If the request count exceeds the limit during the window, further requests are rejected until the next window starts. Example: 100 requests per minute, reset every 60 seconds. Pros: simple to implement and efficient. Works well for small-scale systems. Cons: boundary spikes. A user can send 100 requests at the end of one window and 100 more at the start of the next, effectively sending 200 requests in a short span. Use case: ideal for systems with predictable traffic where spikes are acceptable. B. Sliding window algorithm. How it works. Tracks requests over a rolling time window instead of fixed intervals. As time moves forward, older requests are removed and new ones are added, creating a smooth rate-limiting effect. Example: a 60-second sliding window where the request count is recalculated continuously. Pros: eliminates boundary spikes. Provides smoother traffic control. Cons: requires more complex data structures like a time-stamped queue or list. Higher computational overhead. Use case: best for systems needing fairness and real-time traffic control. SHATC token bucket algorithm. How it works. A bucket is initialized with a fixed number of tokens, capacity. Each request consumes 1 token. Tokens are replenished at a fixed rate, allowing users to make requests as long as tokens are available. Bursts are allowed up to the bucket's capacity. Pros: allows controlled bursts of traffic while maintaining a steady rate. Flexible and easy to tune with bucket size and refill rate. Cons: requires tracking token counts and refill schedules. Use case: ideal for APIs that need to accommodate sudden bursts of traffic, like login or search requests. D. Leaky bucket algorithm. How it works. Requests are added to a queue, the bucket, and leak out at a constant rate. If the bucket overflows, incoming requests are rejected. Pros: ensures a constant flow of traffic without sudden spikes. Highly predictable. Cons: bursts are not allowed unless explicitly configured. Use case: suitable for systems requiring strict traffic control, such as payment gateways. 3. Comparing algorithms. Algorithm traffic control. Bursts allowed. Complexity. Best use case, such as payment gateways. Fixed window. Basic. Yes. Low. Small systems with predictable load. Sliding window. Smooth. Limited. Medium. Real-time fairness. Token bucket. Flexible. Yes, up to capacity. Medium. APIs needing occasional bursts. Leaky bucket. Strict. No. Medium. Systems needing consistent flow. 4. Factors influencing algorithm choice. User experience. Token and sliding window algorithms provide smoother user experiences by allowing bursts or avoiding sudden blocks. System resources. Fixed window is lightweight and suitable for resource-constrained systems, while others may require additional processing. Traffic patterns. Analyze your traffic to determine if bursts are acceptable or if a consistent flow is critical. 5. Practical implementation tips. Hybrid approaches. Combine algorithms to balance simplicity and flexibility, e.g., a token bucket for bursts plus a sliding window for fairness. Testing. Simulate real-world traffic scenarios to evaluate how your chosen algorithm performs under load. Adjust thresholds. Periodically fine-tune thresholds, e.g., request limits, window sizes, based on traffic analysis. Conclusion. Choosing the right algorithm ensures your rate limiter is effective and aligns with your system's requirements. Whether you need simplicity, fairness, or flexibility, each algorithm offers a unique way to balance traffic control with user experience. By understanding these options, you can make an informed decision to protect and optimize your system.